Hey guys, on day one in class we did this function transformations exploration, which it's kind of like I would compare it to like a science lab, only it's math. So you're going to be doing a little bit of experiments kind of. So you'll notice you have, you're going to make some graphs, you're going to observe, make some observations here, you're going to make predictions on what you think different functions will look like, and then you're going to verify using Desmos. So this is all about kind of exploring and discovering some patterns that have to do with transforming parent functions. So with this, you're going to be using Desmos as a tool. You're also going to be using your graphs of basic functions handout, which looks like this. Those should already be filled out, so you kind of have an understanding of what some of these basic functions look like, right? Absolute value, the quadratic, the square root, things like that. So this will be really helpful. I'm going to let you go through this on your own because I think the instructions are pretty good, pretty clear, and you're going to use Desmos on a lot of it anyway. So if you get some parts of it wrong, that's okay. If your predictions are wrong, that's okay. You're going to use Desmos, like I said, to verify. But I did want to go over kind of one of the last parts with you because we talked about this a little bit in class as kind of a summary of what we learned. So again, I would go through this on your own first. Don't jump right to this section. So, if you haven't done this yet, open up Desmos, grab your assignment, and go through up to this part. Once you're done with that, you can come back and I'll kind of show you how to do this. All right, so if you're watching this, you should have already finished parts A through D. But what I want to show you is just kind of a compare and contrast here with how these different transformations look for different functions, because they're actually going to be pretty similar. Okay, the first four are what we call translations, right? So another way to put translations is shifts. Okay, we can go up, down, left, or right. Now the vertical shifts happen after like the main operation. So if you kind of notice in each of these here, you have some kind of operation, right? X squared, square root, absolute value. This is 2 to the power of x. And the vertical shifts happen after or outside those main operations. So if you wanted to vertically shift a graph up 4, up 1, sorry. You would just put a +1 outside, like at the end, after the function, basically. Okay, so 2 to the x plus 1. Okay, all those will shift the parent function of each of these graphs up 1 unit. Okay, and this is the generic way you write that. You have your function, and you add 1 at the very end, after the function. Okay, down is very similar, so you're going to subtract 5, and again, that's going to come basically after the main function, after whatever operation you're doing. Okay, so those are all down 5 shifts. Okay, now horizontal shifts are a little bit different because what we want to do is we want to adjust the x directly, or we want to change the x value, the input value, before the main operation happens. So what we need is a grouping symbol that will change the order of operations so that we change the x before whatever operation we're doing. In this case, I'm going to use parentheses to show that I'm going to do something to x before I square it. Okay. Now this is kind of tricky, but you probably would have discovered this or seen this as you did your activity here. But a shift to the right of 3, kind of weird. You actually put a -3. That's a little bit counterintuitive. The reason why is if you're subtracting 3 from any of your inputs, what you got to do is you got to pick bigger inputs. Okay, you got to pick things that are 3 bigger to account for that subtract 3. So you're picking x values that are 3 bigger, which shifts your graphs to the 3 to the right. Okay, for the square root itself can be a grouping symbol. You just extend the square root bar. Okay, and this would indicate that you're subtracting 3 from x first, and then taking the square root of whatever that value is. Okay, absolute value also acts as a grouping symbol. Okay, so something like that. And then with the exponential function, what you can do is you can keep that -3 in the exponent, and that's kind of a grouping symbol as well. So it's like you got to do the x minus 3 first, then you can take 2 to that power. So we use grouping symbols, different kinds of grouping symbols, to indicate that the change is going to happen to x before the function happens. So if you think about it like this, x squared is kind of like an output. We're adjusting the output, right? We take the square root of x and then we subtract 5. We take the absolute value of x and then subtract 5. So these two were kind of adjusting the output. Here we're kind of adjusting the input. Okay, so for a horizontal shift left 4, again, this is kind of counterintuitive. We got to put a plus 4 on the inside with x. We want to affect x directly. We want to do that first before the main operation. So x plus 4 inside the root, x plus 4 inside the absolute value, x plus 4 inside the exponent. Okay, all those are kind of similar. So that's how you do a shift, up, down, left, right. Okay, now over here is just the generic way of writing that. So notice here that like the plus 1 and the minus 5 are like outside of the f of x representing the output. So you like find the function output like you normally would and then subtract 5 or add 1. Whereas here, notice that I'm adjusting the input. Whatever happens, whatever x is, I subtract 3 first and then I put that into the function. And you can kind of see that here. And this is again the generic way to represent adding 4 to the input before I do whatever operation. Okay, so vertical stretch by a factor of 2. So when you multiply a function by like a number, it either gets taller and skinnier or shorter and fatter. If that number is bigger than 1, it's going to get taller and skinnier. So you can just put that out front. So this is going to be basically take your parabola and stretch it this way. So it's going to look skinnier. It's actually getting taller because all of your basically output values are getting doubled. Okay, so 2 squared of x, 2 absolute value of x, 2 times 2 to the x. All of those are going to stretch your graphs by a factor of 2. Basically what you're going to do is you're going to multiply all your y values by 2 and it's going to be skinnier and taller. Okay, reflections. So if we were to basically negate all of our outputs, all the positive numbers become negative and we kind of reflect over the x-axis. So if we slap a negative out front of our function, that will indicate a reflection over the x-axis. And again, you should have seen that in your activity here. Okay, reflection over the y-axis is kind of similar to this horizontal shift, right? A reflection over the y-axis is like a horizontal reflection. And so what we're going to do is we're actually going to negate x or make x negative before we do the operation. So again, we need grouping symbols to change the order of operations. Because here it's like square x and then make it negative. Take the square root of x and then make it negative. Take the absolute value of x and then make it negative, right? But here we're putting the negative inside whatever that grouping symbol is to indicate that we're adjusting the input and not the output. Okay, so absolute value of negative x and 2 to the negative x power. Okay, those will all be reflections over the y-axis. Okay, and again, on the far right is just like the generic way of stating that. F of negative x is saying put the negative on the x first and then do your operation. This indicates that you're going to kind of do the operation like normal but just slap a negative on the outside. All right, so this is the general way of representing some of those transformations. These are specific to different functions, specific to different parent functions, but this is how you would just say generally if you want to move a function up 1, this is how you do it. Generally, if you want to move a function down 5, then this is how you do it. Okay. Now in your book they have something kind of similar. Of course, this doesn't use specific values. They use things like k, right? Plus k, plus k. Here k is positive. Here's k is negative, right? That kind of thing. H and h. So we use these letters as sliders in our activities to kind of affect the graph, right? Here's a, your vertical stretch factor. And then, of course, here's your reflections, okay? Your homework is going to be doing transformations on graphs. And so I kind of want to show you how to do that as an example. So what I recommend doing is start with the parent function. Identify the parent function. So in this case, we basically got an x squared function, right? This is a quadratic. So the graph that I'm going to have here is just some transformed version of this guy. And since I know what that guy looks like, I'm going to go ahead and put the graph down. This is in your graphs of basic functions. So by this point, 1, 2, 3, 4, you should be pretty familiar with this graph because we've used it a bunch of times. But if you're not yet, then you have that reference sheet that you can use. I would kind of make sure you study that. So that's the original, right? Now each of these numbers, negatives, whatever, is going to affect that graph. It's going to change the appearance of that graph. So what I would do is go in kind of in order here. I would start with reflections and then go stretches and then translations and just list what's happening so that you don't miss them. Okay, so what does this negative do? Well, it's on the outside, right? It's not on the inside. It happens after the square. And so this is going to be a reflection over the x-axis. Okay? There's no stretches or compressions because we're not multiplying x by anything or multiplying x squared by anything. So that's not applicable here. Okay, but for the translations, you can see we have a +2 on the inside with x. So that's going to be a left 2 shift. And then we have a +3 on the outside, like after the square happens. Right? So that's going to happen after. That's going to affect the output. That's going to move it up 3. Okay, so that's kind of what we need to have here. So the graph here, it's going to flip. It's going to start by flipping over the x-axis. I'm going to do this in pencil. This is not my final product, but it's going to look something like this. Okay, that's the first transformation. Okay, there's no stretches, but then I'm going to move it left 2 and up 3. Right, so my graph is going to be like this is called the vertex, kind of the pointy part of the parabola. My vertex is going to be here, and it's going to be pointed down. One, two, three. Okay, so I'm just getting my points here. So the transformation is going to be an upside-down parabola, and its vertex is going to be -2, 3 instead of 0, 0. Okay, so that's kind of how you do multiple shifts. Let's do this other one really quick and then talk about what that looks like. So the original here, this is a square root function. So the parent function is f of x equals x squared. Or sorry, excuse me, square root of x. So I'm going to graph that. Again, hopefully by this point you kind of know what that looks like. But if you don't, you have that reference guide here. So that's the original. Okay. Now we're going to transform it. So we got a reflection, right? A negative on the outside of the root. Okay, that's going to reflect it over the x-axis. Okay, notice we also have a negative on the inside. Okay, that's going to reflect it over the y-axis. So there's 2 reflections here. Okay, also the 2 is going to stretch it by a factor of 2. So it's not only if you think about this as one transformation, it's going to flip it and stretch it at the same time. You could also think of it as like separate, like the negative is going to flip it, the 2 is going to stretch it. But we're going to basically multiply each y value by 2 to get it to be steeper. Okay, and then there's a +3 on the outside of the square root. That means we're going to go up 3. Okay, there's no horizontal shift here, because there's no number inside the parentheses that's adding or subtracting x, inside the root. All right, so this is what we need to do. We need to flip it over the x and the y, we need to stretch it by a factor of 2, and then we need to move it up 3. Okay, so flip it over the x, flip it over the y, okay, something like that. Now, I like to sometimes add my reference points here. So I got that guy. I have the point like 1, 1. That would be like the 1, 1 point. And I also have the point 4, 2. So my 4, 2 point would be like 1, 2, like right here. Okay, so that's the reflection part. Make sure I got that in the right spot. Okay, so that's the reflection. We've reflected it over this axis and then over this axis. Okay, now we need to stretch it by a factor of 2. So basically all your y values are going to double. This one's at 0, 0, so if you double the y value, it's still at 0. This one's at -1, -1. If you double that y value, you should be at -1, -2. And this one's at -4, -2. If you double that y value, you're going to be at -4, -4. Okay, so notice my graph is going to be steeper now, kind of like that. But we now have to move all the points up 3 units. Okay, that's the last shift is the translation. So this guy, instead of being at 0, 0, is going to be at 0, 3. Okay, this guy, instead of being at -1, -2, it's going to go up 1, 2, 3. It's going to be at -1, +1. Okay, and then this one, instead of being at -4, -4, it's going to move up 3 and be at -4, -1. So when all is said and done, I'm going to have something that looks kind of like that. Okay, it's going to be the original. We flipped it, and then we flipped it again, and then we stretched it. I'm going to do all these in pencil here. And then finally we moved it up. And the final graph is this guy, the blue one. Okay, so there's multiple shifts there. When you do your homework, again, I would always start with the parent function. Just identify like what is it going to look like basically. Okay, it's a square root. It's going to look like a square root. It's going to be kind of like that. We're just going to mess with it. We're going to transform it. So list out your transformations. I would always start with reflections and compressions. And then end with your translations. That maybe is like your last move. Otherwise, sometimes the order of operations can kind of get weird there. But that's a couple examples. Your homework is very similar, and there's also some videos posted along with your homework if you need a little bit more experience with, reflections or stretches, compressions, or translations to kind of help you get the rest of the way there. Okay, hope that helped, and thanks for watching.